Mic check, ladies and gentlemen. We are back. This lesson is for you guys, IB year number 2. Hopefully you guys are doing okay. I'd like to start off by saying I miss you guys. Saying that it's a tough road, man. It's tough out here, but we're getting through it. I feel like I've been told that a lot recently. We'll get through it. That's what they keep telling me. So I'm going to tell you too that we're going to get through it because I believe them. Today's lesson is going to be about the carbon cycle again, except it's not going to be about the marine carbon cycle. It's going to be about the terrestrial carbon cycle. I didn't want to do it all together because it's a lot of stuff and a lot of arrows. So what I want to do today is I want to talk about the terrestrial part instead of just the marine part. Okay. I'm going to share the screen and I'm going to show you where in our lab notebooks we are. Okay. Brain jog number 7, which I'm going to assign, is going to go on page 14. The notes we're going to do today is going to go on page 21. So terrestrial carbon cycle on page 21. The reason the brain jogs are so far behind the notes is because we just meet not as often anymore. We used to meet 3 times a week. Now we only do 2 times a week. Okay, so I'm going to stop that share. And I'm going to show you the agenda for today. Where are you? Aha, okay. So number 1 is a brain jog number 7. It'll be about the marine carbon cycle, page 14. Number 2 is I'm going to show you one of the most well-preserved examples of dead bodies ever discovered. They're called bog bodies. These bog bodies are absolutely amazing. They are unbelievably well preserved. They are even more well preserved than the Egyptian mummies. Okay, they're not as old as the mummies, but they're still very well preserved. Okay, number 3 is I'm going to give you another extended DBQ. So instead of the ocean acidification DBQ, I'm going to give you one more, which is about the bog bodies. And you're going to learn exactly where the bog bodies come from and why they're so well preserved. It's pretty neat. Finally, we're going to end with a small note section on the terrestrial carbon cycle. Shouldn't take us that long. Okay. Let's go over the goal of the day today. Where are you? Okay, so here are the 3 goals that we're trying to reach today. So I'm going to read them out loud. Number 1, I want you guys to walk away from this video with an understanding of archaea bacteria. Now, these bacteria are super interesting. They are methanogenic. That means they create methane. They also form methanes in anaerobic wetlands. So we're going to talk about wetlands today. We don't really have any wetlands in Southern California from what I've seen. So I'm going to do my best to try to paint the picture for you. Okay, number 2, you'll also need to understand that methane oxidizes to carbon dioxide in the atmosphere. That's why methane is the 3rd most dangerous greenhouse gas. And finally, we're going to talk about something called peat. Peat, not like the name, P-E-A-T-S. So peat is flammable, and people use it all around the world for fuel. You can actually buy peat at a local grocery store, I think. Okay. Peats form coal from layered, partially decomposed organic matter. So we're going to talk about peat today. Alrighty. So walking away from the lesson, I want you guys to be familiar with archaea bacteria, what methane does in the atmosphere, and what is peat. Those are the 3 goals we're trying to reach. Please remember to write these goals down on page 21, right above the notes that we're going to do. Whoa, that's not what I want. That's not what I want either. Are you going to work? Let's see, is this going to work? Oh boy, we're 5 minutes into the video and I'm having technical difficulties, guys. And I'm recording, so you guys are going to see me try to troubleshoot this in real time. Let's see what I can do. I know. Let's go here. Okay, not working like I would want. Let's try it again. That is quite odd. All right, I'm gonna do this. If you guys are watching this and I get it actually fixed, then what I want you to do is just fast forward the video so you guys can watch it later. Okay, let's see if this works. You gonna work? Aha, it worked. Look at that, ladies and gentlemen, I got it going. Man over machine. Ah, victory, sweet taste of victory. The notes look something like this, ladies and gentlemen. Terrestrial carbon cycle. This goes not on page 19, this will go on page 21. And we're just gonna do these notes. So we're gonna talk about some wetlands. We're gonna talk about what's happening in the terrestrial carbon cycle. So why don't we just dive in, huh? Okay. Okay, so this is called terrestrial carbon cycle. This goes on page 21 of your bills, and you guys are IB cohort number 6. You will always and forever be my favorite cohort number 6. It is looking like we will spend the entire school year distance learning, ladies and gentlemen. And so get comfortable where you are. It's not my ideal, but it is what it is. This is the land. We've already talked about the water on this side, so we're just kind of shifting the camera angle over here to the land part. And what I want to do is I want to draw the central players in our little story today. It's a little tree. Human being right there. Let's draw a little house with a little chimney. And we are going to draw some water on the inland because not all the water is in the ocean. There is some water inland as well. And we can't forget the atmosphere that plays a role in our story also. Atmosphere. CO2. Okay. Again, imagine you are a carbon atom in the atmosphere. This is branching directly from our lesson about climate change. We are going to follow your journey as a carbon atom through the terrestrial carbon cycle, because you don't stay put. You go different places, you travel. So let's start in the atmosphere. You're going to travel from the atmosphere into the plant, and we already know what process that is called. It's called photosynthesis. Now remember to write down this along with me, and I will guide you through it so you can better understand. Okay. Now the plant undergoes cellular respiration as well, so it's going to release some carbon dioxide back into the atmosphere. But it's not the only thing. Animals, protists, fungi, they also release carbon dioxide through cellular respiration as well. Cellular respiration, cell respiration. Okay, I'm going to zoom into a more familiar relationship between the plant and the animals. Sometimes the plant will bear fruit, and that carbon that is transferred from the atmosphere to the fruit through photosynthesis is consumed by the animals. So this process can occur as well. Carbon will transfer from the plant to the animal through a process called consumption. Yum, 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 yum. Maybe as you're watching this video, you're consuming some fruit as well. Consumption is the process of transferring carbon through eating. Transfer carbon through eating. Okay. Now, for most of you, you're going to consume 3-4 times a day, sometimes 6 times a day if you have some snacks for 80 years or so, and then you'll die. So this arrow shows your carbon actually going back into the ground, but don't worry, the plants die with you. Everything that has a life must have a death. So here we go. These arrows represent the process of decomposition. You know, this might be a good time for me to post a video of a pig decomposing. It's like a time-lapse video. It's pretty cool. You get to see what happens to things when they die and decompose. Okay, so this process is called decomposition. Now remember that whenever I ring that bell, that means make a flashcard. Decomposition, it's an academic vocabulary term. The process of carbon moving into the ground, or other organisms like detritivores. Okay. That should make some sense to you guys, because we know that detritivores like to eat detritus. Things that qualify as detritus: dead materials, birds of a feather, not birds of a feather, feathers of a bird. Birds of a feather, that's funny. Okay, so some of your carbon when you die, it will go to other organisms that eat you because you're dead. Some of it will go into the ground, and that's the process of decomposition. So what I'm going to do is I'm going to draw a bone, because after the process of decomposition, sometimes the only thing that's left are the bones in the ground. The carbon in your bones, if you wait long enough, will crush, will heat up, and it will make fossil fuels. If it's a liquid fossil fuel, it is called crude oil. And that process is called deposition. Deposition is the process of heating and crushing organic matter. Okay, I'm going to pause here. This word decomposition is very similar to this word deposition. They even sound very similar. The only difference is really the middle part of the word. Decomposition and deposition. There's an easy way, I think, to remember it. To decompose is to die and to rot. Deposition comes from the word deposit. So an oil deposit is made through the process of deposition. Hopefully that makes sense. An oil deposit, let me just write this down, is made through the process of deposition. Okay. Sometimes the carbon doesn't make oil. Sometimes it crushes in a way that makes diamonds. So diamonds are decomposed carbon. Pretty cool, no? That's not how you draw a diamond, but you guys get the picture. Looks like a, I don't know, like a kite. Okay. Suppose you were to die, but you didn't die in the ground. Suppose you died and you died in the water. Okay, what happens then? So I'm going to make a little arrow and you're going to die in here, Kasplunk. And you're going to die in a very specific location. This location is a swamp. Now, if you've ever seen a swamp, first of all, swamps are amazing. They're super stinky, but they are amazing ecosystems. Swamps are made from stagnant water. Stagnant means not moving, still water. So there's no water going in, no water coming out. The water just stays still. That's a swamp. Okay, what happens if you die in a swamp? Well, here's what happens. You're going to go to the bottom, obviously, because your body will probably sink. And it will settle at the very bottom of this swamp. So I'm going to draw like the first layer of the swamp is here. And everything below, that green layer. Okay. Now, because it's stagnant water and your body and other decomposing organisms are at the very bottom, what's going to happen is that there's not a lot of available oxygen down there. It's very deep. So the only thing that can survive in an oxygen poor environment is something called an anaerobic methanogen. Anaerobic methanogen. Now, what are these little guys? They are a very old kind of bacteria. Super, super old. They are called archaea. Archaea are the oldest organisms on our planet. They've been around since the beginning of life. Archaea, they release, guess what? Methane, CH4. And they will eat away at the organisms that lay on the bottom of that swamp. So this environment class is an anaerobic environment. Okay. This methane does something to the water at the bottom. Because we know methane is made and we know there's no oxygen there, what happens is that this environment begins to become quite acidic. So the anaerobic environment is also acidic. All right, not so bad, right? You die, not a lot of oxygen down there, methane is made, simple. Well, what happens when more things die on top of you? There's more and more people stacked on top of you. It's usually not people, it's like vegetation and stuff, plants. They kind of stack on top of you and it makes a little blanket above where you died. And so this becomes the second layer. This is newer and this is older down here. Well, all that new dead stuff is pushing on the old dead stuff, and that pushing creates a very interesting soil composition. And that soil we call peat. And if you continue to push peat down and you crush it without any oxygen, that peat will eventually, over time, transform into a black rock. And this black rock, you put it in your barbecue, you put it in a fire, it's called coal. Peat will transform to coal over millions and millions of years because this process takes a long time. And even more layers will stack on top of the newer layer and continue the process. And that, ladies and gentlemen, is where we get our coal. This acid, by the way, is a really, really, really good place to preserve a body. So when you guys do the DBQ, how did these bodies become so well preserved? Well, they sank to the bottom of that swamp and was preserved by the non-oxygen environment and by the acidity of that environment. So they ended up being pickled and preserved. If you put a cucumber in some acid, that cucumber will be pickled. And that's exactly what happened to these medieval bodies. You can even still see the wrinkles on their face. It's pretty cool. They're called bog bodies. Bog is another term for a swamp, a bog. Bog bodies. Okay, the story's not done because we started off with you being in the atmosphere as carbon and you moved to the plant Plant moved to the animal then dies, goes to oil, or it can die in the water and gets turned to coal eventually. Okay, well, you guys probably know the end of this story. What do humans do with this oil deposit and these coal deposits? They dig them up from the ground, and then they put them in their homes, and these homes, they burn it for energy, and then your carbon goes back into the atmosphere. This process of taking fossil fuels and burning them is called combustion. Burning fossil fuels. And that, ladies and gentlemen, is the terrestrial carbon cycle. Let me summarize, and I want to give you a few extra stuff for you to understand the world. Okay, the summary: global climate change is a problem. The reason it's a problem is because there's a lot more CO2 in the atmosphere. Now, that CO2 gets cycled through our planet. The carbon sometimes goes to the plant, but then back to the atmosphere. It can sometimes be consumed by animals, and those animals will eventually decompose. The process of decomposition will lead eventually, over millions of years, to deposition. Deposition will create oil deposits, and it will also create coal deposits. Once upon a time, human beings in the Industrial Revolution found these energy reserves, and they started to combust them. They found that if they combusted them, then they have energy available, and then they can power their steam engines and such. This coal is created through the process of anaerobic environments in swamps. That's why you don't have a lot of coal deposits in Los Angeles, because we don't have a lot of swamps. But if you go into states like Kentucky, West Virginia, they have a lot of swamps there. It's quite humid. So those swamps make coal, and that coal is mined by human beings for energy purposes. Now, the coal makers, well, the coal miners probably don't really know about anaerobic methanogens, but maybe one day you'll meet a coal miner, you can tell them about it. This is a very good chance for me to mention the United States' reliance on non-renewable energy. So the king of energy for the United States is oil. It is something we are willing to go to war for. That's how precious oil is, because it is a non-renewable energy source. Once you use up the oil, it's gone. You have to wait another few millions of years for the decomposed organisms to deposit. The number 2 energy source is something called a natural gas. Now, I don't know if I've told you what a natural gas is, so I'm going to tell you right now. In the land, what you have are rocks. These are rocks. And sometimes trapped within the rocks are gases that can be combusted, like CH4, CO2. And the process of fracking, you may have seen this in the news. Fracking is the industrial process of taking these gases out of their rocks and then using them for energy. Seems like a good alternative to oil usage, right? Well, the problem is when you extract the gases from the rocks, sometimes it can lead to earthquakes. That's what's happening, I believe, in states like Oklahoma and Nebraska. I could be wrong about the states, but I know it's happening in the Trans-Mississippi Plains. That's what you call them. The third energy source for Americans is coal. Again, the big three are non-renewable. Once you use them, you have to wait a few million years to get them back. And then number 4 is a group of renewable energy sources. Solar, hydroelectric, wind, nuclear, etc., geothermal. So I think if any of you want to win a Nobel Prize one day, you can come up with a renewable source of energy that does not deposit CO2 into our atmosphere and make climate change worse. That is one of the big mysteries of the modern day. 32 minutes in, I guess it might be a good idea to tell you a quick story. I don't know if you guys have noticed, maybe it's just me. Modern movies these days are trying to discuss this exact issue. The fact that the energy that we use at some point will be depleted. So what do? Civilization must go on, so where do we get our energy from? You see it in movies like, I think it was Iron Man 2, or was it the Avengers or something, where Tony Stark was trying to find another source of energy. And he, in the movie, which is fictional, he was able to find a renewable source of energy that does not release greenhouse gases into the atmosphere. Also, this becomes a political issue because there are some people whose lives depend on oil, natural gas, and coal, and then opponents of these will say, well, we have to switch our energy grid to solar and hydroelectric and wind and nuclear. But then what happens to the people whose lives depend on these industries? So it gets very political, you see? Okay. I wanted to introduce those ideas to you because that's the world we live in, guys. When you turn on your phones, or when you charge your phones, I should say, you are using energy. And that energy is created at a power plant. So when you plug stuff in to a socket, that energy has to come from somewhere. And it comes from a generator in Los Angeles. And that generator is run on natural gas, probably. Okay. I think that is what I wanted to tell you about the terrestrial carbon cycle. I just had an idea. I might want to end here. You see you? It is a myth that human beings are outside of nature. This idea was born probably in the 1800s sometime, that human beings, their role was to control nature. I don't think that's the case. I think human beings have tried to control nature, and that has led to a backfiring. I think human beings have to be reminded time and time again that they are a part of nature and that they share nature with other living organisms on the planet. So walking away from this lesson, yes, the vocabulary, but big picture, don't forget that you're a part of nature. And because you're a part of it, it's a good idea to respect it. Okay, so I'm going to stop this share. And I think, let me take a look one more time at the goals of the day, make sure I got all of them. Archaea bacteria, yes. Methane oxidizes to carbon dioxide. We didn't talk about that, but don't worry about that. And then finally, peats form coal. Yep. Stop the share. And that, ladies and gentlemen, I believe is the end of our lesson today. So this is Mr. Din checking out again. Wishing you guys a wonderful Monday. Miss you all. Bye.